Hi, welcome to Dr. Pat TV. We're looking at areas between two graphs, how to calculate that. And basically what I've got is a four little step process or things to do list. When we're finding areas, that one of the things that first thing we need to do is between two graphs, we need to find out who's the top function and who's the bottom function. Because when we make the integral sign in step number 3, we're going to do top minus bottom. The second piece that we need to do is find our limits of integration. The limits are all about the x values, and so that's more of a left to right kind of thing. And so we want to know when our area starts and where our area stops. Okay, so that's basically the second part. The second part is more concerned with the x values, or the first step when we're looking at top and bottom functions, that's really about the y values. Then we set up our integrals. So we got our limits of integration. That's the left side, right side, and then top minus bottom. And then we actually, step number 4, crunch it out and do the work. Okay, so let's do another example of this. So what we want to do is find the area between the line 3x and that exponential graph, a little bit of a curve to it, 5e to the negative x, and also y-axis. So we're going to have these three pieces, these two graphs on the y-axis. That's going to make an area for us, a section. And so this is what we've got. So we've got the line y equals 3x. Our 5e to the negative x is that curvy line that's decreasing, and what we want to do, and then the y-axis here. So the area that we're looking for is that area right in between there, between those three key components, the two graphs and the y-axis. Okay, and so then by looking at this graph, we can see that the top function is going to be that 5e to the negative x. The bottom function will be the 3x. Now, because the top function, we know who's top and we know who's on bottom, our integral is going to be top function minus bottom function. So that's kind of how we're setting up those integrals. Now, the next stage is to find the limits of integration, those x values, where we start, where we end. So the intersection of those two functions, you just put those two functions equal to each other. Use the solver feature in your calculator or your computer to find that intersection. And so when we do that, I got an approximation of 0.77095. And so there's our intersection. That's where our area is going to stop. The area starts here on the left side at the y-axis. And just remember, if you're on the y-axis, your x value is 0. So basically, we're starting on the left side at 0, and at the right side, we're stopping at 0.77095. And that's an approximation there. I rounded off. And so now, because of those two values, those two x values, we bring them in together, and those are our limits of integration. So we got our limits of integration. Our left side is 0. Our right side is 0.77095. Our top function, and then minus our bottom function. And so there's our integral, all ready to go for us, set up to do the calculation. So now let's just crunch that out. So just remember, we're doing the antiderivative of this, and the antiderivative of an exponential is itself, and then technically divided by the derivative of that negative x, which happens to be a negative 1. And so that's where you're getting this negative 5 here, is the negative is because of that negative there. And then doing the power rule on the 3x there, that's where we're getting the adding 1 to the power, so that's where you get a power 2. Okay, so there's our antiderivative. Next step is this vertical line is just kind of reminding us or telling us to, hey, you still have to plug in the x's and take the difference. And so let's do that. So we plug in 0.77095 into this antiderivative. I crunched it out and I got something like negative 3.2044. That's rounded off again. And then when we plug in 0, what do we get? We get a negative 5. And so then we take the difference here, and those two negatives will kind of make a positive. And so we end up with an area of 1.7956, an approximation there. And so that's the process that we look at. We identify who's the top function, who's the bottom function. So that way we can set up our integral, top minus bottom. We figure out what the left side and the right side are of our area, so that the left side's our lower limit of integration, and our intersection here on the right side is the upper limit of the integration. And then we just basically do the antiderivative, plug in the values, which we're allowed to because we're using the fundamental theorem of calculus. And so that's what we've got for that example. Just an extension on this problem. Hey, what if we integrate? Same formulas in that, basically the same area, but what happens if we integrate from 0 to 1? Now remember on this problem before, we went from 0 to 0.77. So what happens if I go a little bit beyond and actually go to 1? What would happen to this value? Okay, so would the value get larger? Would it get smaller? What do you think would happen? Now here's kind of funny. So you see what we're doing is we're creating this extra area. So if we don't stop at 0.77 and we continue all the way to 1, what we get here is we get this area. But the key thing I want to bring your attention to is that for this second part here, this little extra area, second area, the top function now is the 3x. The bottom function is the exponential. And so what it actually happens is that we get a lower value. So when we go from 0 to 1, that's going to change this value right here. So instead of 0.77, this actual value gets well, it's going to increase. It's going to make more negative. And so in the end, we actually get a smaller value than we did before. And so what we're doing is when your functions switch after an intersection, what happens is this area right here is now actually going to take away from the area that we added previously. And so that's just kind of a little switch there. It's kind of like when your marginal revenue, marginal cost switch, you go from making more money to starting to lose money. Okay, and so that would be the example. And I have another example coming up in part 3. Hope this helped out. Thanks. Bye.